Hey guys, welcome to today's lesson. Today we're looking at Pythagoras in 3D problems. For the most part, pretty straightforward. I might even hit a bit of trick as well as we go through. Okay, first of all, you've done Pythagoras Theorem. We certainly by now should know that a squared plus b squared equals c squared. When looking at a right angled triangle, A, B, and C, A and B, of course, the smaller side, C is the hypotenuse. And if we want to find what one of the smaller sides are, we subtract it away from the hypotenuse squared. And of course, to find those values, we square root their answer, knowing, of course, that our answer must be positive. Therefore, we can ignore the negative value. That's the basis of Pythagoras. You've done that for quite some time now. So this is 3D problems because we're looking at 3D shapes, okay? Looking at cuboids or rectangular prisms, might be pyramids or cones, those kind of things. There's going to be lots of those questions where we're looking at triangles or right angled triangles within those particular solids. So let's look at this first example. Of course, write this out so you've got some notes there and have a crack at it. If you feel like you can do it, just pause it, have a crack at it, and then watch them quickly. So we want to find the length, first of all, of AC. Now, notice that there, because it's a rectangular prism or a cuboid, okay, we know it's a right angle, which means automatically that we can use Pythagoras because we can see that AC squared equals to 6 squared plus 3 squared, okay? We know that AC squared will now equal 36 plus 9. AC squared will equal 45. Therefore, AC equals a square root of 45. Now, one of the things that I think you should start getting used to as well is not leaving it in that form, okay? You should know that 9 fives are 45, therefore that's the same as saying 3 root 5. I like, if it doesn't specify what the answer should be, I like to keep this in exact form. Of course, this is centimeters, so I'm going to put centimeters there. If it says to 1 decimal place or 3 sig figs, then absolutely use your calculator to do that. But in this instance, I'm going to leave it like that because it helps with the next question, believe it or not. Now, the next question then wants you to find the value of AG. Now, you might get a question, right, where it just wants AG. And you have to find AC first because if you look at where AG is, you can kind of see now where my right angled triangle is, where the base of it is the AC from the previous question. Therefore, if I'm looking to this question and I'm trying to find AG, well, AG is still my hypotenuse squared, but now what we're doing is we're doing our root 45 squared, okay, or 3 root 5 squared, and we're adding that now to 4 squared. Now, of course, root 45 squared is just 45. We have 4 squared is 16. Therefore, we have the answer of 61. Now, in order to find AG, we can square root 61, and that's our final answer. And again, you can do decimal rounding or significant figures. That's up to you. I'm going to leave it as root 61 and go from there. Now, C, I put double asterisks there because this is trig. I know we're not doing trig, but I know you have done right angled trig, so we're going to look at it. Find angle CAG to the nearest degree, CAG. So what it's looking for is theta inside there. Now, the thing is, we have 3 lengths. We have actually found AC, AG, and we've got 4 as well. I'm going to use AC and CG. That way I'm going to look at the tan rule because we know that tan theta equals my opposite, well, let's say CG or GC over AC, just so we've got it there. So tan theta equals 4 over root 45. And now I'm going to do tan negative 1 of 4 over root 45. You can see why it's super important to keep that in surd form, okay? So I'm just going to grab my calculator out and I'm going to go shift 10, remembering that I need to be in degrees. I think I am. I'm going to do 4. I'm going to do over the square root of 45. I'm going to press equals there, and I get 30.8, so let's say 31 degrees to the nearest degrees. So look, you can see it's not actually that much harder, okay? It's just the same gear, but inside a solid. If we look at example 2, look, I know you haven't done much of volume yet. You may have done a little bit in year 9, but I've given you the volume formula for a pyramid, or in this case, a circular-based prism, a pyramid, sorry, a circular-based pyramid, which is a cone, and it really is an application of that. So you can see the volume says we want to do 1/3 times pi, which is easy enough, times the radius squared. And the one thing we don't have the radius there. What we can see though is there's a right angled triangle sitting inside there. And so I'm going to say that r squared equals, let's go straight away and say equals 11.4 squared, subtract 9.3 squared. I'm going to say r squared equals, I'm going to type that in, 11.4 squared. I mean, you could do it the longer way, but most of you should be able to do it like this anyway. Okay, so we get r squared equals 43.47. I'm going to square up my answer, of course, because I want what r is. So we get r equals 6.59, knowing that r must be greater than 0, so we can ignore the negative value. Now I can come back up in here, and I'm going to put up here 6.593178293. In other words, use your answer key. Please don't use 6.59 because you want to put the whole answer in. And I'm going to times that by h, making sure that my r is nice and squared. So now on my calculator, I'm going to type in 1 over 3. I'm going to then times it by my pi. I'm going to times it by my answer squared. That's my radius squared. And I'm going to times it by my height. Now my height, of course, was, let's put that in 9.3 because it's your perpendicular height. Oops, I pressed something incorrect there. I didn't get my pi in correctly. There we go. And I think we should get 423.35 ... Let's do 3 significant figures. So 423, and it's going to be centimeters cubed for volume. And just as a side note, we'll do this later on, but we know that 1 centimeter cubed equals 1 milliliter for capacity. Therefore, that could also be 423 milliliters if you want capacity as well. A little bit extra. Gents, have a crack at the questions today. Hope that made sense. Any problems, let me know. I hope you're well, and we'll see you soon.